to the Sprout Room. Yep, we have a separate little room all dedicated to our small integrated amplifier known as Sprout. And my son Scott, that's the love of his life, it's Sprout. He designed it, came up with it, the whole bit. And it's a great little, if you're unfamiliar with Sprout, and we'll get to our subject here, but here's I don't know what this is. Somebody has, it's in for repair, for whatever. But here's a Sprout. Volume control, input selector in the back. It's about the size of a novel. It's $500. It's just a great product. Very, very nice product. Anyway, this is the Sprout Room where we put together the Sprouts. So, Bob in New Jersey asks, "Hi Paul, I'd appreciate explaining the importance of matching the output impedance of a preamp and the input impedance of an amp." That is a very often asked question. I keep seeing on the internet that one should be 10 times higher than the other. Others say it should be 100 times higher. John Atkinson of Stereophile says that if they are not matched properly, you're going to lose bass. I'm just simply confused. Also, if matching the output impedance of a preamp and the input impedance of an amp is important, should one be concerned about matching the output impedance of a CD player and the input impedance of the preamp? Thanks in advance for your answer. Well, Bob, thank you for your question. It's a good one. Let's see if we can try and understand first what these impedances are and what they mean. So if I got my trusty little paper and pencil here. When we in engineering draw amplifiers, we represent them usually as triangles, okay? So let's just say that triangle right here, here's a gazinta and a gazauta, and then that's going to connect up to here, right? So this is the amp, and here's the preamp. Okay, those two little triangles, sorry. So this one has to drive that one. Okay, so the signal is going like that. And the signal is going like this. So we get something into the preamp. The preamp, you're going to turn the volume up and down. And whatever signal is going to come out has to drive the input of the amplifier. And then out here, of course, is your loudspeaker. There's our little picture of a loudspeaker. And it, in turn, has to drive that. So let's start with the loudspeaker. A loudspeaker has, let's say it has an 8 ohm input impedance. And I'm not going to get into that right now, but here's this low input impedance, and that's why the lower the input impedance, the more power it takes to drive it, to keep the voltage coming out the same. Okay, so and that's why you need watts in a power amplifier. But we're not concerning ourselves with that. We want to talk about input impedance. So the amplifier has to have a higher input impedance than the thing driving it. And not to get too discombobulated, I never do. I never stop and tell a story or anything. Well, anyway, actually the same is true here. The output impedance of the amplifier has to be significantly lower than what it's driving. So if you're trying to drive an 8 ohm speaker, you'd better have something like a very, very low, 0.1, 0.01 output impedance in order to drive this speaker. Well, the same can be said here. Now, why? Well, a couple of reasons, and I'll try and get to explain why John Atkinson said you might lose bass, okay? The impedance is the same as we can model it as a simple resistor, okay? And so if you take, how can I explain this easily? Let's see. Sorry, I should have thought this through a little bit better. Well, if we take, let's say we have a 100 ohm resistor, okay? And we're going to have our little preamp here driving that 100 ohm resistor. And so here's our signal, okay? Now, at the output of this resistor, if I put my scope here, we're going to see exactly the same signal here as opposed to here. On either side of this resistor, it'll be the same. But if I were to add another resistor, say, to ground, and remember, ground is 0. Ground, nothing goes past ground. If we do that, and let's say this resistor is 10 ohms, okay, what's going to happen? This signal that starts out here is going to become a little tiny signal there. In fact, that little tiny signal will be 10 times lower than this. Now, I'm not much of an artist, but so if that's 1, then this is 10 times lower. So there's a divided ratio here of resistors. And in fact, that's exactly what's happening between these two products. We can model this preamp. Here's our preamp. And we can, let's say a preamp has an output impedance of 100 ohms. Not unusual. So here's our, can you see that? Here's our 100 ohm, right? Now we're going to feed that into our amplifier, into our power amplifier. And it, on its input, actually does have a resistor to ground. It has to, and that it doesn't matter why. Anyway, trust me, it does, okay? So if this resistor were smaller than this resistor, then the voltage coming out here would be smaller. But that's not what happens. We hope. And this is what John's talking about and what you're reading. If this were to be 10 times higher than the 100 ohms, then this would be 1,000 ohms. And if you drive 100 ohms into 1,000 ohms, the amount of reduction you'll get is very small. Typically, what we see, typically what we see is an amplifier will have an input impedance that's usually around 30K, 30,000 ohms. And a preamp will have an output impedance of something very low, unless it's a tube. A solid state amp like ours, we usually spec 100 ohms. And we want it kind of low because that's going to have to drive a complex impedance of the cable. So here's our little cable, and I don't know how we're going to make a complex impedance, but yeah, we'll have something there. And that's driving 30K. So basically there is no loss of signal at all. I mean, it's minuscule. 100 ohms driving 30K, it's hard to even measure the difference, and we're not going to bother with it. It doesn't matter. Sometimes I've seen these as low as 10K, but that's still 10,000 compared to 100 is quite large. So that rule of thumb of 10 times or 100 times, as long as it's high enough, it doesn't really matter. You just want to make sure that in the specs that this is significantly higher than this. So the problem comes in when we have something like a tube preamp. Now, a tube preamp might have 1,000 ohms output impedance as opposed to 100. And unless it has a solid state buffer on it, which, like our tube preamp, the BHK Signature, it has a solid state MOSFET buffer on its output. So it too has a 100 ohm driving impedance, protecting the tube from what it's going to be feeding over here. All right, last thing, because we're going too long here. John said you might lose some bass. Why would that happen? Well, in the old days, and still today, some preamplifiers have an output capacitor. Okay? So that's probably fairly large because they want to block DC, or they want to, and tubes in particular would have an output capacitor for whatever reason, but it does. And let's say that output capacitor is a real high quality one. A high quality capacitor would be a film capacitor, and the bigger they are, the more expensive they are. So typically we would see like 1 microfarad, or maybe as large as 10 microfarads. The problem here, impedance. A capacitor working into a resistor will start to lose bass. And that this is forming what we would call a high pass filter. Okay, so as this tries to drive this impedance, if this cap isn't big enough, you're going to start losing bass. It'll start rolling the bass off and forming that high pass filter. So if this resistor, which is our power amp over here, if this resistor gets too low relative to the size of this capacitor, then you're going to have a bass roll off, and that's what John was referring to. Generally, if your amplifier is normal, 30K, 22K, 20K, 25K, you're not going to have any problem at all. Not a problem at all. But if it's like 10K or 5K, which is rare, but if it is, you're going to have trouble. I hope that answers your question. Sorry for the rambling, long explanation, but sometimes it's necessary. So talk to you tomorrow. Bye-bye.